Hi everyone. Today we're going to continue our discussion of inverse functions, but we're actually going to figure out how to compute the inverse function or an expression for it given the expression for f. So let's return to one of the first examples that we saw. We had this function f, which was x cubed minus 2, and I asked you to find f inverse of 6. So basically I wanted to know, what do we have to plug in to the function machine to get an output of 6. So the way that we solved this was just by saying if 6 is the output, then what was the input? So we set the expression equal to 6 and we solved for x, and we ended up finding, well, if I add 2 to both sides, then x equals 2. So I had to plug in 2 to get an output of 6. So basically what the inverse function does is your input is some value, which we'll end up calling x because x is just a placeholder, and the output is going to be the number which we had to plug into f to get that number. So let's say it in a different way. If we're trying to solve for the inverse function in general, we don't have a 6 here. We have any variable. So for now, I'll just call it triangle as a spaceholder. And we find the inverse function by doing the exact same thing as above. We say triangle equals some number cubed minus 2, and I want to figure out what this number is. This is going to be the output of the inverse function. Just like 2 was the output of the inverse function when we plugged in 6. So I solve for question mark, and just like we did in the 2 videos ago, I end up finding that question mark equals the cubed root of triangle plus 2. So this expression should be my output when I plug in triangle. So we write this just like we would a normal function. F inverse of x, I'm going to plug something in, and my output is the cubed root of, not triangle anymore, now we use our actual variable x plus 2. So the idea of an inverse function in the function machine setting is you plug something in, maybe call it x, and you run it backwards through the machine, and what you end up getting is the value that you would have plugged in to get x as an output. So the output of f inverse is the input of f. So the key is that the domain and range of f and f inverse switch. In other words, we switch x and y. We switch the roles of x and y. So let's see how that helps us to solve for the inverse function. So what did we do here? Basically, our first step is to write y equals f of x and swap x and y. The roles of x and y switch places. And then step 2 is to solve for x. So here, basically what I did was this would have said, well, yeah, let's go ahead and do it. So here's our function. It looks like y equals x cubed minus 2. If I switch x and y, then it's x equals y cubed minus 2. And solving for y, I end up with cubed root of x plus 2 equals y. This is the inverse function. We'll do a couple more examples in a minute. That was pretty fast. So then how do I check their inverses? I make sure that f of f inverse of x equals x and f inverse of f of x equals x. And that's pretty important. that this is how we check, because this is the definition of an inverse function. Okay, so let's do a bunch of examples. All right, so I have a function f of x equals 3x plus 2, and I want to find f inverse of x and verify that they're inverses. So my first step is to recognize that f of x is the same as y. Now I swap x and y. So y becomes x becomes y, and now I solve for y. So I'll subtract 2 from both sides. I get x minus 2 equals 3y. To isolate y, now I have to divide both sides by 3. So x minus 2 over 3 equals y. This says that the inverse function, f inverse of x, is x minus 2 over 3. So now I need to verify. So let's first compute f of f inverse of x, and I should get x if they're actually inverses. So I'm going to do f of x minus 2 over 3, because that's the inverse, which is 3 times x minus 2 over 3 plus 2. The 3's cancel here, so I get x minus 2 plus 2, which is x. So that direction checks out. Now if I do f inverse of f of x, then I'm doing f inverse of 3x plus 2. I plug that in for x into the inverse function. So I have 3x plus 2 minus 2 over 3. Easy to see that that's also x. So they are in fact inverse functions. Let's do another example. Here we have f of x is 2 minus the 5th root of x, and I want to find the inverse. So I do the same exact procedure. I recognize that f of x is the same as y, so I can rewrite it that way. Now I swap x and y. X equals 2 minus the 5th root of y. Now I'm going to solve for y. So the first thing I need to do is bring this 2 over, end up with x minus 2 equals negative the 5th root of y. I want to undo the negative, so I can multiply both sides by negative 1. Get negative x plus 2 equals the 5th root of y. Now I need to undo the 5th root, so I can raise both sides to the power of 5. Raising to the power of 5 undoes the 5th root. So I have negative x plus 2 to the 5th equals y, which tells me f inverse of x equals negative x plus 2 raised to the 5th power. And now I need to verify that they're inverses. And I do that by composing them. So let's first do f of f inverse of x, and we should get x. So we're going to be doing f of negative x plus 2 to the 5th and that's going to be 2 minus the 5th root of negative x plus 2 to the 5th. The 5th root undoes raising to the 5th power, so this is 2 minus negative x plus 2, which is 2 plus x minus 2, which is x. Then you can also check that f inverse of f of x equals x. I'll have you check this one on your own. Okay, one more tricky example. You'll see one like this on the webboard. Okay, so if f of x equals 3 minus 5x over 2 plus 4x, we need to find f inverse of x and verify that they're inverses. So this isn't hard because it's a different process. It's hard because there's a lot of algebraic manipulation that you need to do to make sure that you get the right answer. So I start out the same way. The expression f is the same as y equals 3 minus 5x over 2 plus 4x. My first step is to swap x and y. So x equals 3 minus 5y over 2 plus 4y. And now I need to solve for y. That's where it gets a little bit tricky. So the first thing I'm going to do, I don't like that there's something in the denominator. So I'll multiply both sides by 2 plus 4y. So on the right-hand side, these 2 plus 4y's cancel. So I'm just left with, and on the left-hand side, I can distribute the x to each term. So I have 2x plus 4yx equals 3 minus 5y. If I want to solve for y, I want to have all the y's on one side of the equation and everything else on the other side. So let me bring this 5y over by adding 5y to both sides. And bring the 2x over to this side by subtracting 2x from both sides. But now I need to solve for y. So you'll notice that y is a common factor of both of these terms, so I can pull it out. In the first term, when I pull out y, I'm left with 4x. From the second term, I'm left with just 5. And the other side doesn't change. I haven't changed the expression at all. Now to isolate y, I just need to divide both sides by 4x plus 5. So I get y equals 3 minus 2x over, and I'll just switch the order of these, so 5 plus 4x. That's no different. So this is f inverse of x. Now I need to check that they're inverses, and I'll just check one direction and have you check the other. So we'll do f of f inverse of x. So I'm doing f of 3 minus 2x divided by 5 plus 4x. And so that means I'm plugging this into the f function. So you just need to be really neat and careful here. So 3 minus 5 times all of this, and the whole thing divided by 2 plus 4 times all of this. Now again, I've got this nasty denominator. I can get rid of it by multiplying top and bottom by 5 plus 4x. This is just 1, right? So I'm multiplying by 1 in a clever way. So now I end up with 3. I have to distribute this to both of the terms. So I have 3 times 5 plus 4x minus 5 times 3 minus 2x. Because when I multiply 5 plus 4x by this term, this will cancel with the denominator. Similarly, on bottom, I have 2 times 5 plus 4x. And when I multiply 5 plus 4x times this term, it cancels with the denominator, so I have plus 4 times 3 minus 2x. Now just distributing this out and simplifying, I have 15 plus 12x on the first term, minus 15 plus 10x, divided by, so then I have 10 plus 8x plus 12 minus 8x. So on the top, 15 minus 15 is 0, and 12x plus 10x is 22x. On bottom, 10 plus 12 is 22, 8x minus 8x is 0, and so I'm left with x. So they are in fact inverses. Let me know if you have questions, and good luck with the homework.